Hello everyone. The topic which I have chosen is directions in crystals. I am Abhilasha Saini and I am an assistant professor in Mumbai. Let's start with the session. Before starting this session, there are some things which you should know already about the crystal structures. First of all, you should be knowing different types of crystal structures, about what are the lattice points and bases are, and then the knowledge of planes in the crystal should be there with you. And initially what we require is that the unit cell and what are the basis vectors. So I hope all these things you have already studied well before defining the directions in the crystal. Let's start the session. So first of all, we will define what is the meaning of direction in the crystal. So like in our usual life, we know that what the direction is. If you are standing somewhere, so you require a reference point with respect to where you are moving. You need to define that. So that we call simply as directions. So in the same way, the direction in the crystal structure is simply a line that joins any two lattice points in the crystal. Okay. Now the indices of direction can be found by resolving the vector component of that point along the three axes. Okay. That means simply the vector component of any of the point in the three-dimensional structure defines as the indices of the direction. Okay. Now, there is a specific way to write the indices of the directions. So, how to write that? For writing the indices of any point, if you are defining as direction, is that you need to write the indices in this bracket. This is the square bracket, and when you write the indices, there should not be any comma in between. So, for example, if you define the direction by HKL, so here it is written in a square bracket without any comma in between. Okay. Now for simplicity, we just draw the direction as the line joining any lattice point from the origin. So from simplicity, we just join that point from the origin. Okay. Let me understand this with an example here. See, in the example, it is shown we have taken a unit cell, and here O is the origin, and we have taken different points. Say the point B is here, the point A is here, the point C is here. Okay. Now you all know how to find out the vector component of any point. That is the part of our study in mathematics. So here each and every point's vector component, we know it already. Okay. Now if you want to define the direction, say OB or the point A. Okay. So in the here now you can pause the video for a minute and then think that what should be the indices of the direction OA here as explained in the previous slide. What I have explained in the previous slide, what should be the direction of the point OA. Okay. So the answer should be, if we have thought about the this question, the answer should be 1, 1, 1. Why is it so? Because if you see the point A here with respect to the point A, if you incident the perpendicular along X, Y and Z axis, you get 1, 1, 1. For writing the direction, you will simply, the point A is 1, 1, 1. The direction should be defined in a square bracket. So point A is having the vector component as 1, 1, 1. Okay. I hope all of you understood well what the direction means and how do we write them.